Okay, folks, I am not sure how this video presentation is going to kick in with with the WebEx. Sometimes when I launch a number of video files, this is about an hour and 10 minutes long, sum total of all of them. Sometimes it just gives me all kinds of headache. So very delicately, I'm not even moving. I'm just looking at the screen and I'm going to click the files to open. I would like you to just pay attention to what is going to be shown. There's a wide variety of applications from painting to food industry applications to machine loading applications to welding applications and so on. There would be a question centered on this. I wouldn't say exactly what's shown in the video is not what's going to be asked. Watching the video will let you come up with the answers to one question in this area probably a lot easier. Okay, so make your own notes if you want, whatever, but just watch the video. Okay, so I'm going to click only the first row of files. Okay, and see what happens. Okay, why is it play open? Okay, let me know quickly whether you see the video coming up on the screen. I want to minimize the screen. Okay, let's start again. Come on, open. You opened. Well, I get a big circle around. Hopefully, it's just gonna launch. Now it says it's gonna close the program. Pretty sure. Not sure whether WebEx is the problem. My files will open up normally on my laptop. Absolutely no difficulty. Okay, while it is doing something, I have no idea what it is doing. Either it's trying to read the files after opening once or whatever. Any questions do you have on whatever that has been done so far?
I just have kind of one question about PLC programming, if we have time for it.
Yep,
Um,
good.
Normally, when I've programmed something, it's been with text, like in Python or Java or C++. It's always been using text to program something. But PLCs seem to use ladder logic. Is
Yes.
there a reason PLCs can't be programmed normally, like other controllers, like an Arduino?
Okay. PLC cannot be programmed that way because it's already mnemonic code that is built in. It's a micro assembler. So why would you want to not open it up? Go around in the industry, look at automation applications. Would people want to sit down and have someone with the knowledge of Python or Java or C++ and writing codes in that level to get an automation? Or would industry prefer something like PLC where you have a software which is pretty easy to use? You don't deal with code writing. but it gets the job done much better than you're writing a code, because when you write a code, you got to debug, okay, and make sure all of it works. Industry doesn't wait, okay? So that answers your first part. Okay, second part, can I do process automation writing custom code on my own? I've done quite a bit of this in the lab using high-ended I/O interface. That means you plug a card, PC based, or a laptop with a USB hookup. You pay 500, 600, 700, 800, 1000, depending on how many you have. They will give you a library, but you have to write codes of what exactly a ladder logic will do. Okay? So, yes, for a research environment, that's what I have used. Then MEC 2112, it used to be 2012 when I taught it. The whole course was centered around CAD, CAM, producing parts for a line following machine to do a specific task, which is inspecting potholes on the floor, inspecting for gas leak on the floor, simulated, okay? Launching a projectile to a target for a northern environment, delivery of packages instead of drone. What was the mechanical design of the gadgets, plus on top is an Arduino, which the students will have to write codes, okay, to program that Arduino to read sensors and launch this or do this or whatever. So that's another route. So it is possible to do process automation if you're if you have good experience in code writing and you have good experience in understanding Arduino's language or interface language. You're proficient in a certain programming language, right? So you want to do it that way. If so, yes, I can very well train you to go. That's what I did in MEC 2112 or 2012 when it was 2012. But the bus stops there. Nobody was following after that course in doing anything in programming interfaces. This is what I asked the ECE department to do, something like this in their course. I guess it fell into deaf ears. Nothing happened. When I say why nobody does, it's a lot of work to get into this as a course project, just the way I'm burning on hands-on experience. These days, not very many takers. The bottom line is process automation. I wouldn't go the other way of taking an interface and programming such as Arduino, Raspberry. First of all, Arduino, Raspberry will not meet the industry standard, because they're not interfaces that are bulletproof. Even in MEC 2012, out of 23 groups, by the end, I probably will have 4 blown Arduinos. Okay? So they are not rugged. Plus, to make them talk to devices which are high power requires a lot more interfacing and experience. So that's the answer I would give. Very long, going around telling you all the issues about it. So is your question answered? Who asked?
Yeah, that answers most of it. Yeah, thank you.
Okay. Any other question? Folks, I am going to Control Alt Delete because I'm stuck and it's not booting up or whatever. Sign out. Hello, folks. Can you hear me?
Yeah, I can hear you.
I can hear you.
Okay. Now I'm going to venture and see whether the share will work. Okay, I see it here. Share. Come on. Up. Oh. Okay, now. Okay, my screen is up. Wanting to show something. Hey, do you see something? Do you see a painting robot?
We still just see your files.
Did you see a film?
Nope, still nothing.
Still nothing. I'm able to see it here. Oh, crap. Share content is what I did.
Dr. Ballard, are you trying to open all of the files at once?
Nope. That works with the laptop, no problem, but with WebEx, no. I have opened only 5, and now I'm down to 1. Okay, I am now down to 1. Let's see whether it'll play. No, it's a pretty big file. Okay, so can't play. Now it is playing. Can you see it now?
No, we still can't.
No?
No. Are you sharing only only the Files app?
No, I'm sharing the content, and the content is File Explorer with all the files. That's
Or
how.
but you like to share your entire screen?
See, do you see anything right now with all the files?
Just see the files.
Huh? You just see the files, right?
Yeah.
I'm going to click on one. Okay, I'm not even pill sorter. Okay, it should be on a share mode. Okay, share content, File Explorer, share. I just want to open. Now let's see what happens. Just opening only one. Play. Open. What do you see now?
Still the files.
Still files?
Yeah.
Okay, how about if I say share?
Is there an option that says share desktop?
Now what do you see?
We see your WebEx screen. Like, I think you're only sharing one app at a time rather than the entire desktop. So if you click on do screen one,
Did you see anything at all?
right now all I see is just a gray screen.
Okay, folks, I don't know what exactly I should do. Everything seems to work when I start it. Something goes wrong. I will sort it
Is
out.
it possible to send us the video by email or something?
No, it's a pretty big file, and second, this is copyrighted. In the sense, it's been given to me with special permission not to share, but to use it for the students. It's close to 37 gigabyte. I only took 1 hour. I have about 39 hours of video. So I'll do something about it, but right now I am going to move on with a standby. Okay, let me go to this. Okay, do you see my PowerPoint slide?
It's just loading for me right now. Yeah, now we can see it.
I am not sure whether I want to be an IT guy. Sort all this out. This is the stuff I hate about the online stuff when I'm using so many different things. It wants to screw me up. Okay, I'm going to present the last section on the PLC that I did not do as part of my first 3 sets. This is the 4th set. What it is going to show you is how the sequence dependency of the ladder logic may cause problems in only a few cases. So you got to watch out. It could be even your own project number 3. Okay? So let me give you one example. So basically I have a robot cell. And the robot cell, let's not worry about what's happening inside the cell. Some process is going on and the robot is the principal assembler or loader or whatever. So we don't care about the process inside. We care about the safety curtain that's built around the robot cell. This is industry requirement. Manitoba Safety would not approve anything if it does not have a safety curtain around it. Exceptions are my robot cell in the lab, where physical plants tried to put the wrench on me. Several times they attempted, saying that I can't use the cell unless I put a safety curtain. So I said, go to faculty office. It's going to cost $150,000 plus you charging $100,000 to install. No problem. But let me tell you, when it comes to student use, the safety cell is going to be a big hindrance. So I would not even recommend, right? So anyway, it's gone. But in the industry, you can't get by. You got to put a safety curtain. So this particular robot cell has several gates, let's pretend, built as part of the safety curtain. So in this case, I'm going to consider 5 gates located in from different sides of the cell. What is the purpose of the gates? When an operator wants to get inside the cell to make some adjustments, he or she can get through any one of the 5 gates, and they're all going to trip a kind of a sensor which is going to send a command to the PLC. And the alarm is an alarm, assume, will sound for 30 seconds. Okay? During that 30 seconds, when the operator has opened by mistake one of the gates without powering the robot down or powering the cell down, the alarm will come on for 30 seconds. But as soon as he or she opens the door, the robot will shut instantaneously, like an emergency stop. Okay? And power will remain shut off to the robot under the process until all the gates are closed. It could be 1, 2, 3, 4, or all 5, depending on whichever gate is open, should be brought back and shut. Okay? And then you hit a system restart. Very simple. We are only looking at the safety system in the system. Okay, so like before, we are not going to go and do exotic truth table, whatever. Let's look at what is the sequence dependency. Okay, so all the safety switches are emergency power offs. There are many alarms inside the robot cabinet which can be wired to external monitors. For example, my 2 robots Motor Man that I'm currently using for undergraduate courses has got close to 484 alarms inside. In the sense, they're all in the controller. You can wire them up to give you a display, but they have wired them up into the screen, putting out what that alarm. There is an alarm and it is stopped. What does it mean? So if you know what that error code is, you can debug. An example would be Well, the robot's sensors are constantly powered, like the shaft encoders on each axis are always kept alive, even if you power it off. And there is a battery that powers and keeps the memory going. When the battery goes down, typically about 2 to 3 years, unless you wake up ahead of time and as a prevention you keep changing the batteries, it will come up with an alarm and it causes a lot of other headaches. Okay, so there is a code for it. Like this, there are many codes about the heating of the cabinet, heating of the controller, heating of the motors, and so on. So quite a lot of alarms are there, but right now we are looking at only one. So there is a start and a stop push button for starting the process normally after a shutdown or whatever. Okay, so let's look at what the inputs would be. One, the start button go is pressed, equal to 1. When the go button is not pressed, it bounces back. So this is a momentary on off switch. Only the go button, which means on switch. Okay, so I'm going to call it as the variable G. Then there is a stop button. Okay, so the stop button is independent of the start button, and it has got two states. It's also spring momentary on switch. S equal to 1 and S equal to 0. Again, as it says, pressed and not pressed. Then you have 5 gates. Each one has a sensor. So I'm going to call it as E subscript I equal to 1 or a 0, and the I would take the values of 1 to 5. Okay, so would I be considering more? Well, I can consider more, but right now, to make the problem simpler and to show you the sequence independency, I'm not introducing more. I'm not even considering the process. Outputs, I'm going to put a variable R to tell me that the robot is going to be on and equal to 0 when it is off. And I'm going to have the alarm, light or whatever, equal to 1 when it is sounding or lighting up, or 0 when it is off. Okay, the alarm is going to be a net effect of any one of the emergency, any one of the gates being opened. Okay, all that you need is one gate to be opened, boom, alarm should come on. Okay, I am going to put some internal outputs, and the internal output in this case is going to be a timer, because we said in the opening statement the alarm should sound for 30 seconds and then quit. Okay, so I am going to have put a timer as an internal output equal to 1 when the timer has expired. That means it's powered up. And t equal to 0 when it is counting down or not even activated. Okay, so having got this, just proceed to getting the equations. First, you have the emergency on or off. So emergency E, one single variable coming out of the 5 subvariables, would be either E1 or E2 or E3 or E4 or E5, not and. One of them are. Okay, then we can use number of different ways, not E equals E1 or E2 or E3 or E4 or E5, not. Okay, or using de Morgan's law, you can also express it as not E equals E1 not, and E2 not, and E3 not, and E4 not, and E5 not. Okay, it has got no bearing on how I'm going to show the ladder logic. Okay, it has a bearing, but wait. Okay, so assume I did all the analysis. like all my case studies, either going to the truth table or using intuition or whatever. And I came up with the equations, and then I got the ladder logic. Okay, so I transcribed my equation into a ladder logic, and I used my own intuition to put them in this order. The order I thought is the way the process is moving. So the first rung, it could each be a separate rung. Here all of them are shown as 4 ladders as part of a one big rung. Okay, it doesn't matter, they both will function the same. So based on my writing the ladder logic diagram or casting the ladder logic diagram, I have the first ladder which says if R and E joined, or the alarm and not the timer set the alarm. That's my first line. Then I have not E1 and not E2 and not E3 and not E4 and not E5 equals not E. So I'm using the De Morgan's law, putting it in. Then I have the start button and the stop button and the robot working and the emergency as the third ladder. If G is pressed and, not and, if G is pressed or the robot starts running and not S, which is the stop button not pressed, and not E, that means emergency is not on, get the robot going. Okay. Then the last line says alarm triggers a timer. If the alarm stays on for 30 seconds, the timer will become true. Okay. So this is what I got. Okay. There are a number of different ways of casting this. Okay. Now let's look at this. Is there any kind of judgment that I made to put it in this order? Why should be the third ladder, which is the startup operation? That's where I would start. G or R, blah, blah, blah. Get the robot going. That's where normally I would start. Right? And then I would put the condition, which is the rung, not rung, ladder 2, the emergency not being on. Then I will go to the first rung, which triggers the alarm. And in the end, I will put the alarm. But I just threw them in without paying any attention to whether the sequence is important or not important. Okay. So what will happen? Let's look at this diagram. Everything is off. Gates are all closed. No reason, the robot is not running. It's the beginning of the day. The timer is not on because there is no alarm. Everything is going to start. Right? So I come and press the G. I make the G equal to 1. I have not pressed the stop button. I have not opened the gate. So when once I press the G, momentarily it becomes true. Bang, R will start running. Then I'm going to release G, but the R as an R operation in ladder 3 will keep the robot going. Okay, will anything else be on? Look at the first ladder. R is true. and the E, is it true? I have not opened any gate. So it is not true. As a result, the timer is not going to be activated at all because there is no alarm. The alarm will not come on, which is what it should be. The R on the first ladder, A, will not be true, so no harm done. Alarm will not be on. Okay? Process is running normally. And I walk to the cell and I'm going to muck this system down. I opened E3. The cheapish smile that I am going to trigger a big alarm in the industry. So not E is true. Okay. So what will happen? E is true. Robot was running. E became true. Timer is not active yet. A will come on. And A will start the timer. At the end of 30 seconds, timer becomes true. Okay. So what will happen in the first ladder? Not T, not T will become true. Wait. Okay. Purpose is served. Well, the ladder is working. Why do I care? I'm going to show you in the wind loader after I make this presentation. Okay. So now I'm putting the statement. The sequence of the rung is important. So we know the first one worked by intuition. We can check it with the simulation on the loader. What happens when rung 2 is at the top, followed by 3, followed by 1, followed by 4? So we are looking at 2 at the top, okay. So the second line, not E1 and not E2, is now going to go to the top, okay, and followed by 3, the 1, the 4. Well, I just got it from the equation, so who cares? Is the sequence important? You try loading this into the wind loader, alarm will not sound. As if it doesn't exist. Why? Okay, what will happen is, remember, PLCs work this way. They are scanning from top to bottom at a very high speed. Okay, the first place they start is rung 1 or ladder 1, go all the way down and keep coming back. Okay, all are momentary switches in this case, so it's going to be scanning from top to bottom. So if I open the gate, E, the emergency, would turn off the robot even before the alarm has a chance to come on. Okay, so let's look at the ladder. So I am changing the sequence. E moves up. And remember, the first ladder has R and a E. So the R and the E is not going to be true, right? That means alarm will not come on. There's no chance. And even if you go close the gate, the robot is going to shut off. So the alarm will not sound by just changing one sequence here. Okay. Can I fiddle around with the ladder logic to fix this problem? If I made a mistake, and push the sequence out of whack? Can I still fix it by making some modifications to the screwed up ladder? The answer is yes. In some cases you can, some cases you won't be able to. Let me tell you that the sequence dependency is not something that is going to happen in 95% of the cases. May not be critical at all. There are odd cases such as what I am showing you is where it is critical. Also in the past with the PLC projects, I have had this problem when the students say, oh, I bet my ladder is correct, but it is not working. It is that PLC that is a crap, or your model is a crap. Or they won't say that. But so the bottom line is some part of the ladder, they had this coming into play. Okay, so if the ladder that you create appears to be good for you, but it doesn't work, there is a chance that this sequence is making it critical. Okay, so we will look at what's the alternate solution. We also want to look at, well, we are in the first the case that I presented and the ladder logic I presented. The alarm will keep sounding for 30 seconds. Well, you came to the cell and you had a cup of coffee in your hand and your hand was on the gate and suddenly it opened. You did not mean to open it, but you opened it, right? So in the first solution, it doesn't matter. The alarm will keep going on for 30 seconds, even if you close the door. You'll time that 30 seconds and then quit. Okay? So you will really look like a idiot in front of everybody because it would alert everybody. Like in my neighborhood, there is one house. I don't know what exactly happens. Oh, their security alarm in the house at 6:30 in the morning will literally wake up everybody in the neighborhood because they must have put it outside. And it will be about 15 minutes before it shuts off. So either during arming it before going to work and they didn't pay attention, there was a slight time delay and they took off because usually house security gives you about 10 seconds, 15 seconds, or 1 minute. You can adjust before it arms. After you arm it, you go, close the door, and walk away for 1 minute. Nothing happens, and then it locks. But if you open the door before that 1 minute, the alarm will sound. Okay? So, what should we do now to make sure that if you close the door, immediately the alarm goes down? Which is more, as it says in the screen, more practical. Yes, I agree. Okay. So, look at this diagram, which is no different from the first one. It's exactly identical, but look right here. Let me see whether I can get my mouse to work as a pen. Yes. Okay, look here. The previous one is here. This dotted line was the previous one. Now I changed this. It's R, capital R, the logical operation A, and then and E and not T. Not R and E, R, alarm, joined here, and then the rest. This simple fix I'll show you in the ladder, will fix that the moment you close the emergency door, the alarm will quit. It won't go for the 30 seconds. It's a little simple fix. Okay. Okay. So no problem. First solution only needed a slight change. So there are 3 issues that I have talked about. There's a little presentation. 1, PHY gates contributing to an alarm, robot power being switched on by a momentary on switch, which bounces back to an off that doesn't control system off, and then there is a separate button, which is the kill switch, and then there is an alarm and a timer. The first solution provided in a solution that is workable. Alarm sounds for 30 seconds. No matter what you do with the emergency gate, it'll keep going. It'll do its job and quit after 30 seconds. If you want to quit right away, the second slight modification that I showed you is an alternate solution. And as it says, it's more practical. That's up to you whether you want it to be a sounding for 30 seconds or 1 minute or 30 minutes. It's your call. You can program the timer. The third case is by switching the lines to happen. The second one moves to the top and the third one comes to the second and so on. You find the alarm is not even going to come on because it got turned off in the very first line by the emergency. Examine the ladder. I have not posted these notes yet. Okay, so these are the sort of what you would glean out of sequence is important. Not in all cases, majority of cases, maybe not, but in some cases, it is very important. After 3 or 4 heavy-duty industry-based automation projects that I have done for the last number of years, every one of them, they're all not simple projects, they are massive. A lot of ladders and so on. It's heavy-duty automation. There were 1 or 2 where the sequence had to be looked at because what I thought is perfect didn't go. Okay? And all this was not done in a matter of 5 weeks or 4 weeks at 15 hours like what you are doing. All 3 months to 6 months project. I was not working on it full time. A student was paid to work under my guidance, and he did. One case it was a she. So when it didn't work, this is what you're looking at. Okay. Now I'm going to close this. I'm going to open the WinLoader. Your content is my WinLoader. Yes, here it's here. Okay, do you see WinLoader screen? It's the PowerPoint. I'm sharing it. Yes or no?
Yeah, we can see it.
Okay. I am going to open Okay, where is my document? Camp. Sequence. Okay, first solution. Okay, do you see the ladder screen?
Yeah.
Okay, so this is the first solution. I am going to do a move away WebEx. It's now going on top of my screen. Okay, online. Simulation. Okay, so the screen has opened up with whatever that is true. I'm using an internal output M followed by 4 zeros in place of normal using timer as a direct input. I am going to use it to trigger the timer. Okay. So nothing is on. Emergency not true or not on is true. Okay, as it shows here, the green. So what should I do? I am going to get the go button going. Okay, the stop button is not pressed, emergency is not on, robot is not running, which is in the third and fourth ladder. Then the robot arm is not powered. So I'm going to press the go, momentary on and off. So I switched on the I followed by 4 zeros, which is the go button. I switched it on. I got the robot arm going, robot run, output Q followed by 4 zeros. Nothing else is on. So robot is happily running. And I walk into the cell. Look at the timer. It's got value of 10. Instead of 30 seconds, I only put 10. We can change it. So I'm going to open gate number 4, which is I followed by 0005. Aha, my alarm is going to be on at the top. Yes. Okay. Timer is counting for 30 seconds. Let me do it again. Okay. So now timer has expired and the alarm has quit. Okay. Let's do it again. I'm going to reset everything. I'm going to close this door. Okay. No emergency on. I'm going to have the, is anything else on? No, timer has bounced back to 10. So let's go here and get the robot going and switch it off. Robot is running. This would be seen. Why is it not running? Why is it not running here? Okay. So stop button is pressed. Emergency is not on. Let's get this going again. Yes, robot is running now. Okay. I switched off the go button, and since I took my hand off, robot is running. No alarm. Okay, I am going to trip this switch now. Alarm has come on, as you see right at the top. Okay, how long? Oh, it's going on, and I have not closed the gate. Okay, alarm has quit after 10 seconds. Right? So let's do this again. I'm going to close this gate. I'm going to get the robot going again. I'm going to quit. And I'm going to open this gate. Okay, alarm is coming on and I'm going to close the gate. What happened to the alarm? Yeah, it's still on. It's counting 10 seconds. So even though I reacted quick, the alarm kept going. This could be it logged into the computer as an event 1 if you want. Okay. Now let's take the second solution. Okay, I am going to pull my second one. Okay, first I do the sequence. I will do the sequence dependency in the end. So this is the second solution where look at the rung 1 and 2. No, I don't want to save. 1 and 2 are joined together. Unlike the previous one, it is now joined as robot arm and alarm. So I'm going to run this program. Well, it's still loading or doing something. Okay, simulation. Okay, where am I? All the gates are closed like before. I come and start the robot by pressing the button. Yes, robot arm is alive. No emergency, no alarm, everything is intact. Okay, now I want to just show you this screen. I'm going to open the gate now. Alarm is on and I'm going to close the gate immediately. Alarm went off. It didn't wait for the 10 seconds. As soon as you close the door, the alarm goes. Okay, just this little modification here does the job. Depending on which one you prefer, both are correct. Okay, now comes the next one. Sequence change. Okay. Oh. Now I like what I had presented in my PowerPoint slides. I shifted the emergency line is at right at the top. Okay, so let's do the simulation of this. Simulation. Okay, so all gates are closed, no emergency. The go button is not pressed. Okay, so I am going to put the go button first. Robot is not running. The alarm has already come on. Timer does not even play a role. Wait. Yes. The robot has come on. Okay. Now I am going to press this stop button. The robot has quit. Good. So it should behave. Now I'm going to get this go button going again. Switch it off. Robot arm is going. Now what am I going to do? I'm going to close one of these gates, rather open one of these gates. Okay. Robot arm quit. No alarm. So somebody messing with the system. I won't even know that it has been tripped. Okay. So no alarm because this one controls now everything And because that emergency is coming into this line, it did not even trigger the alarm. What happens if I close the door now? Okay. Well, you can now mess the system without being noticed, without being responsible for whatever that was going to be happening inside the system that got screwed up because you opened the gate and the process got terminated. And if this was the ladder, if you didn't know how to get the robot going again, you just open the gate, that's it. It's going to remain dead. Nobody would know unless somebody walks by because the alarm never came. Right? So it clearly shows that the sequence change of the ladder in this case didn't do the job of what it should be doing to generate an alarm in this case, in this problem. We have not even added any of the process variables and what happens inside and so on. We haven't done anything about it. Then the problem will become a lot more complex. Okay, I have something like this embedded for demonstration, my robot cell, but I can't bring this to online presentation. Going to be there in the lab, yes. Any questions? As I say, this is not something I can put statistically will happen 50% of the time or 20% of the time. As far as I know, it is very small percentage, but if something doesn't work, you have to watch. You have to look at the logic to see whether it is messing up somewhere. Okay? So there are not a whole lot of, in fact, these are all not textbook stuff at all. They're all coming from whatever I have collected. So there is no examples that I can say, oh, go and read this reference, you will see more examples. It's something that you should be aware of and watch if you are going to be involved in some PLC implementation. Okay, any questions? Okay, so it's too bad that I got the little stuff messed up with the video, but I will definitely bring it back on Tuesday. I am going to see what exactly I should do. Maybe I cannot play all of them together in one shot. I did not open today all of them. Maybe I should try now. See whether it's still alive. Well, on screen I see it. Okay. I have to do the share first. Share content. A Windows Explorer. I am not sure whether putting them all in one subdirectory is causing the headache. Okay, let me open this. Tell me whether you see the video on the screen. I did share. Should I share just that slide? I don't. Did you see a video presentation of a robot spraying something?
No, we can't.
You didn't. Okay, let me try one other route. Is it? Now, why do this? How do I get to the share here? Immediately share. Not content. Putting only this. If I minimize the screen. It's the whole WebEx. It's opening on my screen. I can see it. Okay, open, share with Skype, share with Skype. Oh, share. Where do I share then? Share. There's a share within that share. The app can share right now. Okay. This and share. Share content. It's taking me back to the Windows Explorer. Maybe I have to load a few files up. I have to figure it out. If you guys know, do you see my screen with showing what the share stuff is? The first one is screen 1, second is Windows
No.
Explorer with a bunch of
Just
files. Do you see it?
just the files. Just the files.
Okay, just the files. If somebody can figure out how I can open it into the WebEx, send me an email, but I will do my work. Okay, folks, this is what's going to happen. I'm absolutely out of action tomorrow. My eyes are going to be dilated like nobody's business. They told me for 3 hours. This is a prior cataract surgery consultation. So I can't even see the screen tomorrow till late in the evening. But I should be up and running on Saturday and Sunday. I will be sending you the feedback for the project 2 on this weekend. I'm almost done. Okay. Then I have to set the final exam now, this weekend, so that I can give you an idea as to what it is going to be. Bottom line is study my notes. Then you are going to apply what's in the notes to solve whatever. So, you know how to do the truth table, if you know how to do the logic equations, if you know how to use the corner map, if you got the project 2, the CNC stuff, maybe there will be some spot questions. Robot, whatever I have dumped into the D2L, read it. If I can't show the video, I will not ask questions on the video, which are applications. Okay, so that's all I can say. Any questions before I sign off? Okay, there is a lab this afternoon. 2 wants to join from you. Should send me mail. Invite you just after I open the WebEx. Okay, bye for now.